What if we built a ring world in space? Imagine a structure far beyond the scope of any engineering endeavor humanity has attempted so far. A colossal ring encircling an entire star, spanning millions of kilometers, designed to house trillions of inhabitants and provide an effectively limitless landscape under artificial gravity and eternal sunshine. This is the concept known as a ring world, first conceived by author Larry Niven in his 1970 science fiction novel Ringworld. The idea has captured the imagination of scientists, engineers, and dreamers ever since. As we explore what it would mean to build a ring world in space, we'll delve into the staggering engineering challenges, the astronomical resources required, the possible environments and cultures that could emerge, and the implications for energy, society, and the future of humanity itself. To begin, let's try to grasp the sheer scale of a ring world. Unlike a Dyson sphere, which fully encloses a star, a ring world is a thin ribbon or band set at roughly the same radius as a planet's orbit, circling all the way around a sun. Imagine Earth's orbit transposed as a single, unimaginably vast metallic ring, hovering at 150 million kilometers from the sun and forming a gigantic artificial surface. The ring could be a few thousand kilometers wide, offering far more living area than all the planets in our solar system combined. People on world Earth might compare it to an endless plain, no discernible curvature, perpetual sunlight pouring down, and the glorious sight of the sun always fixed at the same relative position in the sky. The first challenge in building such a thing is the question of materials. The ring world idea swiftly exposes the limits of human technology. No known material could withstand the structural stresses involved if built at the scales described in science fiction. The tensile strength required to construct a continuous, habitable ring at Earth's orbital radius is far beyond that of steel, carbon fiber, or even the strongest materials we can currently produce. Speculative materials, such as carbon nanotubes or graphene, might possess the necessary properties, but even those exist only in very small quantities and have yet to be manufactured or assembled at truly industrial scales. The second concern is gravity. On Earth, we walk atop a ball, pulled inward by the mass beneath us. On a ring world, you'd need to simulate this experience by utilizing centrifugal force. The entire ring would spin around the sun, fast enough that objects and people standing on the inner rim would be pressed down by inertia. If designed carefully, this precisely calculated spin could mimic Earth-like gravity on the ring world's floor. However, managing that spin introduces a whole new set of engineering concerns. The ring must remain perfectly balanced. Any wobble in its rotation could cause it to drift toward the sun or into deep space, with catastrophic results. Keeping the ring stable in three-dimensional space would be an epic and possibly insurmountable challenge. Ordinary orbital dynamics tell us that solid rings are inherently unstable. Any small perturbation could lead the ring to oscillate and eventually crash into the star or veer out of orbit. Some have proposed solutions, like active stabilization, whereby enormous thrusters and guidance systems are constantly adjusting to keep the ring centered, using feedback from a vast array of sensors. More exotic ideas involve magnetic fields or solar sails, nudging the structure back into perfect alignment. But all of these require flawless engineering and unimaginable amounts of energy. The staggering size of the ring world implies an equally staggering cost in terms of resources and energy to construct it. Just rough calculations of mass show that you'd need to dismantle entire planets, or even several, to assemble the ring's raw material. If you harvested all of Mercury, for instance, you might barely manage enough mass to lay down the base of such a ring. The project would need colossal fleets of automated mining and assembly robots, capable of demolishing planets and processing the debris into usable forms, and then hauling those components across millions of kilometers with ruthless efficiency. This is not merely a global, nor even a solar system-wide project. It is a truly stellar undertaking, requiring a society of near godlike technological prowess. Suppose that, in some far future, an advanced civilization achieves these feats. What would life be like upon a ring world? The population limit is, effectively, astronomical. trillions of individuals could have their own homesteads, cities, or even countries. The land area available would millions of times greater than the entirety of Earth. There would be endless room for natural reserves, experimental environments, and biodiversity far beyond what any single planet could host. The geography could be anything the builders desire: vast swaths of forests, meandering rivers, snow-capped mountains, enormous cities separated by hundreds of kilometers. Weather could be controlled and stabilized, since the ring has no axial tilt to create seasons, and no night, except perhaps where artificial shading devices are installed. The sun would always hang above, never moving, a fixed and reliable anchor to the sky. Darkness, if it occurred, would be intentional, the result of careful shading or deliberate engineering. Beneath the surface allure of endless terrain lies a deeper sociological impact. A ring world could support not just individual societies, nations, or languages, but entire civilizations evolving independently along its boundless arc. Travel across the full circumference, hundreds of millions of kilometers, could take weeks, months, or even years, creating geographic and cultural isolation. Imagining the development of a dozen or 1,000 distinct civilizations along the ring fires the imagination. Perhaps some sections would be left wild. Others would develop hyper-urban metropolises. Others still would engage in bizarre terraforming experiments, or even new forms of intentional ecosystem design. Energy production on the ring would, for all practical purposes, be unlimited. The proximity to a star allows direct collection of solar energy at a scale unrivaled by anything else. Every surface, city, and device could be solar-powered, and advanced energy storage could mitigate the perpetual sunlight. Space launching would become trivial, as materials could be lofted off the surface at incredible speeds due to the ring's rotation. Reaching escape velocity would be a matter of proper trajectory and timing. Interplanetary or even interstellar exploration might become routine. But this scenario raises questions of governance, coordination, and law. With so many beings, potentially of diverse species, cultures, or even cognitive architectures, how are resources managed? Do governments spring up along each segment, forming a patchwork of sovereign entities? Will ring-world societies remain unified or splinter into competing groups? What happens when sections of the ring become isolated or develop unique identities, philosophies, or religions? Communication, transportation, and information networks would need to exceed even the scale of today's global internet, unifying or navigating these bewildering variations into a coherent whole. The construction and maintenance of the ring world would demand technological systems beyond comprehension. To survive micrometeorite impacts, cosmic radiation, and normal wear and tear, the ring's surface and underlying infrastructure would require continuous repair, perhaps managed by nanobots or self-replicating machines. Maintenance would have to be flawlessly automated. The prospect of traveling from one end of the ring to another just to patch a breach would be infeasible for organic life alone. Yet, with these risks come possibilities for resilience. The ring could be equipped with redundant systems, sealed layers of atmosphere, secondary power networks, distributed computers to manage maintenance, weather, and artificial intelligence, tasked with anticipating and repairing faults before catastrophe strikes. In a sense, the ring world itself could become a living system, a meta-organism sustained by the intelligence and activity of both its inhabitants and its machine overseers. A question then arises: who would build such a ring world? It's unlikely that humanity in its current early 21st century form could ever muster the organizational, social, and technical unity for such an endeavor. Instead, most thinkers envision a Type II civilization on the Kardashev scale, one that harnesses the entire energy output of a star, being capable of such feats. Such civilizations might not merely inhabit planets, but reshape and engineer entire solar systems, building megastructures as naturally as we build cities today. Should we ever contemplate constructing a ring world, the transformation would not be limited to physics and engineering. It would fundamentally alter our understanding of what it is to live, to work, to coexist. The scale of society would balloon beyond familiar concepts. Privacy, community, fame, and even crime would take on new meanings. The psychological and existential ramifications would ripple through our cultures. Some inhabitants might feel a sense of cosmic insignificance or isolation, while others could revel in the boundless opportunity. But there are even more radical possibilities. A ringworld need not be a single, continuous, homogeneous environment. It might be sectioned into climates and biomes that vary completely from one arc to another. Some regions could simulate alpine mountain ranges, others vast forests or prairies, tropical jungles, complex archipelagos of islands nestled within engineered lakes, all maintained by advanced control over water, air, and sun. For the first time, climate and weather would be fully intentional phenomena, subject to ongoing fine-tuning and cultural project. Were some sections to fall under neglect or rebellion, or simply be abandoned, they could become wild frontiers, ripe for explorers or pioneers seeking challenge and adventure. Myths and legends would grow around the lost regions of the ring. The interconnected history and discovery of such a world would play out over thousands, perhaps millions, of years. Moreover, consider the potential for non-human life or artificial intelligence. If our future includes cohabitation with machine minds or uplifted animals, the ringworld's habitats could support intelligences of diverse physical forms and cognitive capabilities. One region might support traditional humans, another engineered superhumans with greater physical or mental faculties, others vast cloud-like collectives of software entities or entirely new life forms that evolve in tandem with artificial environments. Integration and conflict between these modes of existence could pulse along the ring's endless circuits, but it's also possible that only fragments or partial ringworlds will ever be built. Perhaps beginnings of such megastructures assembled as rings of orbiting habitats, or a ring, composed of a connected network of O'Neill cylinders and other space colonies. Even these partial measures would dwarf anything humanity has yet constructed, and with continued advances, could form stepping stones toward the ultimate ringworld. While speculative, such thought experiments force us to confront the limits and possibilities of future expansion. Where energy is abundant and space ceases to be a limitation, what forms of art, culture, politics, and even consciousness might arise? Could the ring become the cradle of post-biological civilizations, using the structure as a substrate for digital minds, simulated worlds, or centuries-long creative endeavors? And yet, the ringworld presents risks and vulnerabilities unique to its form. A disruption to its spin, a breach in its structure, a massive collision with an asteroid, or failure in the stabilization systems could threaten entire regions, perhaps causing the loss of thousands of kilometers of landscape. Civilizations may develop traditions of vigilance and redundancy, always wary of flaws within their colossal home. Some have speculated that in the cosmic search for extraterrestrial civilizations, the presence of a ringworld would be visible even across interstellar distances, as a stark and inexplicable ring of light encircling a star. If, in our exploration of the galaxy, we observed such an anomaly, it might signal the existence of an advanced, ancient civilization, with philosophies and technologies beyond human reckoning. The leap from fiction to fact, however, is daunting. The technical hurdles, constructing with perfect strength and stability, defending against cosmic threats, assembling and transporting resources, aren't minor, but surmountable only by a society having not only technological might, but cohesive, long-term unity. It's a vision for a far, far future, one where the boundaries of the possible are testaments to ambition as much as to science. Still, envisioning a ringworld illuminates our own present limitations, spurring the pursuit of new sciences, advanced materials research, planetary engineering, artificial intelligence, and the mastery of clean, star-scale energy. Our first baby steps into space, building stations, robots on Mars, and giant telescopes, are the smallest taste of what may one day be within our reach. The concept of the ringworld invites us to imagine not just new worlds, but new ways of understanding ourselves. Would we remain Earthlings in spirit, or become something wholly new, ring dwellers, starlings, children of engineering and solar might? Might the vastness engender humility, or simply become the new normal, our descendants as casual about visiting the next ark as we are about crossing continents today? For all its science fiction roots, the Ringworld is an aspirational symbol, a vision of human or post-human ingenuity, adaptability, and hope on the largest possible scale. Whether it remains forever fiction or someday emerges as fact, the idea pushes us to expand our imagination, challenge our assumptions, and reflect on what it means to build not just structures, but homes, societies, and futures in the most unlikely of places, the endless plains circling a star. Thank you for watching the video. What do you think about today's topic? Feel free to share your thoughts in the comments below. If you enjoyed it, don't forget to like and share the video to support the channel. Thanks again, and see you in the next video.